I hope you all are doing well. So today's topic is Mid-Point Theorem. Okay. So this is an explanation of the entire concept of Mid-Point Theorem, right? So it states that the line segment joining the midpoint of any two sides of a triangle. Say ABC is the triangle and the two sides they are talking about is AB and AC, and the midpoints are E and F. Alright, so the line segment joining the midpoint of any two sides of a triangle, which means EF, is parallel to the third side. BC is considered as the third side, guys. Okay, so we have to prove that EF is parallel to BC and EF is equal to half of BC, right? So this is the whole contention, and we'll try and prove this with the help of this diagram. All right, so in construction, all right, so given I have explained that triangle ABC is here, E and F are the midpoints of AB and AC, and RTF is that EF, RTP is required to prove is EF is parallel to BC. EF is parallel to BC and EF is equal to half BC. In construction, we draw a line from C, okay, in a manner that it is parallel to BA. Alright guys, and EF is joined, which is produced further to intersect on line, okay, produced from C, okay, infinitely, and it intersects at a point D on this line. Correct? So have we got it? So having done this, we now proceed to prove it. How do we prove? First of all, my step 1 would be to prove with the help of congruency. So congruency in the sense that when two triangles, okay, so in this case we consider AEF and CDF, they got to be equal in terms of their angles as well as sides, okay, equal to each other, correct? And to be able to do so, there are certain conditions. As you know, in congruency we use conditions like RHS, SAS, AAS, okay, you can write this ASA also, and then we have SSS. Alright guys, so as simple as this. So in this case we'll consider this and this to prove our congruency. So doing, we'll get certain elements which can help us in proving what our contention or RTP is, right? So this angle is equal to this angle. This angle is equal to this angle. This is equal to this because it's vertically opposite angles. Alright, when two lines intersect each other, we know that the angles formed on the opposite side of the two intersecting lines are equal to each other. We have done in lower classes. We have this angle A will be equal to angle ACD, right? So in this case it will be considered as FCD, correct? So this is alternate to this because we have two parallel lines, and this will be equal to this. This is considered as alternate because this parallel line and this parallel line is being intersected by a transversal, and transversals always, okay, bring about alternate angles on the opposite sides, right? So this is how we have. Next we have that F being the midpoint of AC, we have AF equals to FC. So this is the included side, and these two angles of this, okay, triangle, and these two angles are corresponding angles. Okay, So by CPCT, now we know that AE is equal to CD. Got it? And EF equals to FD. Okay, you will get them all here. Okay, when you go through them. So we have these tenets. Okay, these are the elements of statements that we have to write with their reasons. You have to write the reasons along with. Okay, so thus we are able to prove the congruency of A, E, F and C, D, F. Guys, so this is as per AAS congruency rule. Correct? So by CPCT we prove that AE is equal to CD, EF equals to FD, and this was already there. This angle was already there. This equals to this, and this one, okay, will be equal to this. Correct? This we could have done without the congruency because this is another transversal which is cutting the two parallel lines. So which means this is alternate to this. Correct? So having done this, now we have set a scenario where we'll be able to reach easily to this two contentions. How do we prove that? Now that having done the congruency, we know that we have in hand AE equals to CD. Alright? And if this is equal to CD, which means AE, which was equal to BE, CD becomes equals to BE. Alright? Let me repeat. AE had been equal to BE because E is a midpoint. And AE now is equal to CD. Alright? By congruency we have proved by CPCT. So CD becomes indirectly equal to BE. And we already know that this is parallel to this. So which means that according to the property of parallelogram, if we have one pair of opposite sides parallel as well as equal, we can say that that quadrilateral is a parallelogram. Automatically we know that ED is running parallel to this, as BCDE is a parallelogram. Got it? So this is running parallel to this, which means not only ED but EF too is running parallel to BC, as EF produced is ED. So first one we have been able to prove. Next one we prove that EF is equal to half BC. How? Do we not know that EF is equal to FD? So can we not write that because BC is equal to ED, BC is equal to ED and ED is to EF. Okay? So which means EF is equal to half BC. Got it? So this is how we prove, isn't it? So this is the whole thing. So midpoint theorem is not difficult, just that these are geometrical properties which you have to know, to be able to crack several more complex riders that you will be doing in future. So guys, I hope you people have understood. In case there is still a query, do write to me in the comment section. I'll appreciate that, and let's engage so that we are able to understand better each other, and I can also fulfill whatever are your requirements as per your syllabus. Okay guys, so thank you so much, and it was wonderful teaching you all. Just in case you have liked this video, do subscribe. It gives us a lot of motivation. That's all I can say guys. Have a nice time. Bye bye.